Welcome, scholars. Today we shall be looking at graph, and to take you on this ride is Namdi Okechukwu, and I want you to relax, get your pen, and be ready as we are going to enjoy this ride. Some of the content or outline for this topic is Cartesian plane. We shall be looking at the Cartesian plane. That is the first one, and then we shall also be looking at quadrants of a graph. Quadrants of a graph. Also, shall be looking at coordinates. Shall be looking at coordinates. Now, let's swing into action. Linear graph. Linear graphs are used to represent relationship between two variables that are proportional to each other. In a linear graph, the relationship between the two variables is represented by a straight line. The variables in a linear graph are typically plotted on the x and y axis. Now you can see in the example here the straight line which passes through the origin. This is a graph of a function y is equal to x. This is a linear graph. This is a straight line graph. We are going to understand more of this as we go further. Now let's look at what Cartesian plane is. The Cartesian plane, also known as the coordinate plane, is a two-dimensional plane that is used to graphically represent mathematical equations and functions. So that's what our Cartesian plane is. And then we say that the plane consists of two perpendicular number lines that intersect at their respective 0 points, which are marked by the coordinates 0, 0. We are going to be seeing a picture of the Cartesian plane in the next slide, and there we'll be able to explain more about it. Now, in that Cartesian plane, the horizontal number line, we've talked about number line before, is called the x-axis, while the vertical number line is called the y-axis. Together, they divide the plane into 4 quadrants. Later on, we shall be discussing quadrants in full. Now, let's take a picture or take a look at the Cartesian plane. Now, the vertical line, as we can see there, which is represented by y, is the y-axis. The horizontal line, that's the one that is lying, is the x-axis. And the point where the two of them intersect is called the origin, represented by 0. So let's quickly look at what quadrant is. In mathematics, a graph is a visual representation of a set of points, typically in a coordinate system. The quadrant of a graph is one of the 4 regions formed by the intersection of the x-axis, the horizontal axis, and the y-axis, the vertical axis, at their origin 0, 0. Now, these quadrants can actually be numbered as 1, 2, 3, and 4, as we are going to see in the diagram in the next slide. Why sometimes number it as Q1, Q2, Q3, and Q4. Now these are number line, a graphical representation of the Cartesian plane. We can see at the top right, that's the first quadrant, and at the top left, that's the second quadrant, and at the bottom left, that's the third quadrant, and at the bottom right, the fourth quadrant. Now we can actually look at that arrow, which tells us that the quadrants are counted in the anti-clockwise direction. So the arrow there indicates how we actually move our movement, just like when we measure an angle. Angles are measured in the anti-clockwise direction. You know what we mean by anti-clockwise, so against the direction of the clock. Now let us quickly look at our quadrants. So the x and y axis divide the Cartesian plane into 4 regions, and these regions are called quadrants. They are numbered as Q1, Q2, Q3, and Q4, as shown in the diagram in the anti-clockwise direction. The first quadrant is denoted as Q1, the second quadrant as Q2, and so on. Now, the right hand side towards the east from the y-axis is considered the positive direction, while the left hand side towards the west from the y-axis is considered the negative direction. The upward direction towards the north from the x-axis is the positive direction, and the downward side towards the south is the negative direction. Every point in the plane is denoted by a unique ordered pair. Having talked about the quadrant, let us look at the coordinates. In mathematics, a coordinate is a numerical value that specifies the position of a point in a particular space or system. Now let's look at this in a graphical context. In the context of a graph, a coordinate refers to a pair of values x, y that specifies the location of a point on the graph. So your coordinate, as we have said, is a unique ordered pair which can actually specify the location of the points on the graph. The coordinate plane allows us to graph a pair of ordered data. The first element of an ordered pair represents its x value, its horizontal position, while its y value represents its vertical position, how far up and down it is on the plane. Let's go through this example to plot points. So let's look at the first example. We have 2, 3, move 2 places to the right, and then 3 places upwards, and we'll be able to locate that point. Now, the second example, we have -3, -3, and -5. So we'll move 3 places to the left and 5 places downwards. So we'll be able to locate that point. And the other one, we have 6, -2, -2, which will move 6 places to the right on the x-axis and 2 places on the y-axis. Now we have -3 and 0. We move 3 places to the left, and because the y-axis indicates 0, so we will not move and we'll locate a point there. Meanwhile, we can actually tell where our coordinates can be found in the Cartesian plane. If it's going to be on the first quadrant, second quadrant, third quadrant, or the fourth quadrant. So for it to be in the first quadrant, the both have to be positive. For the second quadrant, the x is negative and the y is positive. Now, let's see how we can identify coordinates on the coordinate plane. Now, the horizontal line is our x-axis and the vertical line is our y-axis. Coordinates are given to us as x, y. And the x coordinate is written first, while the y coordinate second. Note that. So we are going to identify point A. We trace from point A to the x-axis and trace to the y-axis, which gives us 5. Point location A is 5, 6. Now, wasn't this easy? It's very easy. Let's look at point B. Let's look at point B, how we go about that. Trace to the x-axis and then trace to the y-axis. You can see that our point B gives us negative 3, positive 3. Yes, and then let's look at point C, which is on 6, and because it doesn't move, we write 6, and then the y traced to the y-axis gives us 0. So that is negative 6, 0. We're going to talk about that later on. D, the location D, we trace to the horizontal axis or the x-axis, and that falls at the mark negative 7. And then we also trace to the y-axis, which gives us negative 6. That you can see it's actually in the third quadrant, so which is negative 7 and negative 6. So for E, we trace to the x-axis, which gives us a 2, and then we trace to the y-axis, which falls at negative 5, and you can see that that is actually in the fourth quadrant, which gives us 2, negative 5. And for F is actually on the y-axis, which tells you there is no movement on the x-axis, and that tells you that the x-axis is 0 and the y coordinate is 4. Now, like I was saying, we'll be able to, whenever you have points on the x-axis, you have a point on the x-axis, that means the y coordinate is 0. And when you have points on the y-axis, it tells you that the x is 0. Now we have our first quadrant, second quadrant, third quadrant, and fourth quadrant. On the first quadrant, both coordinates are positive. On the second quadrant, the x coordinate is negative and the y coordinate positive. On the third quadrant, both coordinates are negative. On the fourth quadrant, the x coordinate is positive and the y coordinate is negative. Now there are points on the vertical line and points on the horizontal line. That's the points on the y-axis. They are actually at a neutral position. They do not belong to any quadrants. And this is where we draw the curtain. Bye.